Hello, my name is Nnamdi Ajah. I'm a hardware engineer with Cloudflare. I'm mostly focused on developing an OpenBMC for our server fleet distributed around the world. Sorry, I caught a little bit of cold while coming over from Germany. Cloudflare provides a number of services, and every time you literally access any of our services, you're accessing one of our servers, and you access one of our servers, and our servers are managed by a lot of different teams. The SRE is the provisioning teams that are not hardware focused, and a lot of times these teams have the requirement to change the UEFI configuration of these servers. Also, these people who every now and then need to change these settings are not conversant with namespaces, with UEFI, and all the mechanics that work on it. So we needed a way to be able to make it easy for them, like intuitive for them to be able to change the settings without having to come to us to ping us every minute. And we also needed it to be like for there to be one single source of truth for every UEFI settings for each SKU of server that we had. Yeah, so we had this goal, which is up there for various teams to be able to manage it without depending specifically on one team. Yeah, and just in case you get bored before the end of the presentation, what we really were able to do was we were able to come up with a vendor-neutral tool, a tool that works across different OEMs, across different generations. Sometimes per OEM, we have 3 different generations of servers, 4 different generations of servers are spread across. And of course, depending on the server type, storage compute, we will need to modify the settings per requirement. Also, different kinds of UEFI settings, one-off options, lists, booleans, and all of that. We also needed it to be able to work with our existing automation infrastructure, so that it's something that our teams already use, and so we didn't want to introduce something foreign to them. We wanted to wanted to keep what they are still used to, using YAML or Ginger scripts to manage our servers. Yeah. So and also we before now, every time we needed to make a configuration change, we would reach out to our OEMs and ask, "Oh, okay, please, can you make this change for us?" And that would require building a new building a new UEFI, testing, and everything else involved with it, which of course took a lot of time. So with the tool we were able to develop, it's got all of this. Our tool has been able to work across all the vendors we use, across different generations of servers. Yeah, so what are the challenges we faced? I've mentioned some, multiple generations, and you would all agree with me that even for a specific UEFI vendor, across various versions, sometimes the interfaces can be different. The interfaces can be different. The Redfish endpoints also can be different, and sometimes on certain generations, like on our older generations, Redfish support is not available. And for the most part, also some of our teams, like I mentioned earlier, are not conversant with UEFI terminology, e.g., the security folks and the SRE folks and all of that. Yeah, so we considered a couple of different options. We said, "Oh, okay, should we put a Redfish wrapper?" And then that meant that we would have to enumerate through almost every endpoint, and then we would have to do vendor mapping for each attribute. And then we said, "Oh, how about if we use we also said, okay, some of the vendors also provide proprietary tooling to be able to to be able to modify the settings, but then it meant that we would have to put an API to sit in between and to be able to interface with all of this, with all of this tooling, and of course, then the legal issues, having to sign non-disclosure agreements and all of that. Also, it would mean that to a good part of it, we would have to read a whole lot of documentations from the vendors to do all of the mapping. Well, we came about to saying it just seemed best for us to be able to develop an UEFI application that would sit independent of the main BIOS firmware, and then it will be called when the boot manager is just about calling the exit boot services. Yeah, it would call the application, and then we could pass on whatever configurations we needed for the. We could pass on whatever configurations we needed for that particular kind of server. Before now, we had also used iPXE. We had patched iPXE. It had worked to some extent, but the more we scaled our services, the more we expanded our network, we started to hit barriers. There were a number of settings, e.g. pH randomization, that it could not get. The code was becoming really bloated. And then it meant that every time we had to update iPXE, we literally had to carry the patch around with us, which made it not easy to maintain. Yeah, so what we've been able to do is, for the vendor neutral tool, we used the prompt string. So when you go to the UEFI settings, when you go to the GUI, which is what the non-conversant UEFI person would go to, that's what the SRE person knows, that's what the security person knows. They know the prompt strings that is written there. Oh, they know secure bots, they know pH randomization, they know COM0 ports. So we take those those prompt strings, and then we call the HII, we call the HII APIs, and then we get the opcodes, and from the opcodes we get the VASTOR, and from there we are able to view and modify the settings of the UEFI of the variable that we want to change. Yeah, so this is really just a breakdown of how we do it. One important thing to note for us, like I said earlier, is it makes us not reliant on a particular pre-boot execution shell. Yeah, and the way it works is when the reset vector on the metal is called, after PI and the boot manager is called, it runs iPXE, our pre-boot execution environment. What iPXE does is iPXE downloads the signed HI configuration app, and then the settings that we want per SKU or for the server is already downloaded. iPXE also downloads it, and then it takes those settings and then passes it to the configuration app. And what happens next is the configuration app reads the settings, and then we compare the values of the settings with what we expect. And if it does not, if there's a mismatch, we then update the settings. However, if there's no mismatch, excuse me, if there's no mismatch, then it exists gracefully and continues with the boot logic. Yeah, so this really is how it is. This is a YAML configuration, and then we say, okay, the product name of a server could be OEM A Gen A 2025, and then we define the UEFI settings here. So for this one, we have USB mass storage driver support. For those of us who every now and then play with these settings here, these are quite familiar. Like I said earlier, we purposely did not use the namespaces because the other teams are really not familiar with the namespaces. This is what they are familiar with, and we wanted something that it's intuitive for them to use, that they could just really just enter it into a document or a CLI, and then it gets the settings for them. So yeah, the operator only needs to know the prompt strings, in this case, USB mass storage, COM0, media detect, and we can see that it supports different types. We can see booleans there, we can see numbers there, and we can see one-off options there. Yeah, so this is how we run it. We use iPXE. So iPXE just calls it in a loop and say, oh, okay, for each of the values we have in the settings, please, for each of the keys we have in the configuration, please show it, and then we do a comparison. And if there is a mismatch, we then go to the set settings. This is typical of what it looks like. Yeah, so when it runs, it gives us something like this. We can see, e.g., for the COM0 terminal, the options we have there are VT10, VT100, VT100 plus VTUTF-8. Just a minute. Just a bit of... Yeah, okay. It's a bit... The resolution, some of the text is hidden, but just underneath the text, you would also see the current value of the settings. Yeah, and just in case there's a mismatch, like, so if it says, oh, okay, what I have in my buffer value is not equal to what I have in the value, it then goes to the set settings, and the set settings is just similar like the show settings. It sets the key to the value. And then, something similar also, it shows, oh, okay, I'm setting configuration, measure the text count, e.g. to 2. My opcode is this, my numeric op is this to that, and then it also shows the step. So this is important because it helps people, it helps the SRE or whoever the operator to know what's being done and the kind of how to increment it and the kind of values to enter. Yeah, we can see the GUID, the widths, and the offsets and the value to be entered. And then it gives us a success message. Yeah, with this tool, we've also been able to use it to improve our updates infrastructure for our subcomponents, CPL, the UEFI, and all of that. The way we do that is we create FEVAs, and then we put metadata related to all of these subcomponents that we update. So this information is not it's not available because this information is custom to us. We define them, so we don't ask our OEM to put them in the BIOS before setting it. With what we have with this tool, we also can be able to create and set custom settings to be able to make our updates infrastructure more robust. Yeah. Also, the tool can get all the SMBIOS settings and export it over IPMI, over Redfish to the BMC, and then the BMC can then expose it over the available defined Redfish endpoints. Yeah, so in all, we've been able to develop a vendor-neutral tool. It works well across different OEMs, across different generations. It's able to take complex configurations. It integrates with our automation infrastructure. It's really easy to use. People who are not familiar with UEFI terminology, with how it works, are able to just go to the YAML and then describe the settings that they want, put the settings that they want, and then it gets deployed on tens of thousands of servers, and it's easy to maintain. I would have loved to do a demo. Reason why I was trying to connect my computer, unfortunately, it did not work out. Yeah. Questions, please.
Any questions? No? Okay. Yeah. Okay. All right. Thank you, Nnamdi.
All right.